And what I'm going to try and acquaint you today with is the buzzword that's happening around in the IT industry, which is cloud, right? Um, before we begin, what I would like to tell you is about various tables of content, like what we're going to read through, right? So the first thing is going to be the introduction to cloud itself, following which I will give you an overview of what cloud is, and then some fundamentals that are required for understanding. Now, I did look at the brochure for this webinar, and it was for computer science students, right? So that is something that we would need to look at, because we would need to understand that you understand the computer science fundamentals to be on cloud, right? Similarly, following that, we'll have a few concepts and what are the various types of architecture slash service models which are currently available in the cloud. And again, what I would really like to stress on is the fact that this is a very introductory lecture or a webinar, right? So this is going to be on a very high level, but it's going to touch all the points that's necessary for you to understand what cloud is. So moving on, let's begin with the introduction. Now, before we begin with the introduction, the first thing that I want to do is, if all of you could open up a web page, right, and go to menti.com, right, www.menti.com. And when you go there, it will prompt you for a code. Put in the code as 2727 2750. Now, what will happen is you will see a page which is something like this, which will ask you this question, right? What is your current profession? So what we're trying to understand here is, let's see what the crowd is, who the crowd is. So if you're an undergraduate student, please just type in 1 in the answer box and push enter. I will get your vote. Similarly, if you're a graduate student, you can type 2. If you're a professional, 3, and the other options are available. I hope nobody is forced to be here, so I don't get a 6, right? So I'm going to go ahead and wait for a minute exactly, right? So as to understand what are the people that we currently have. Okay. So I see we have a Cloud Yoda already. So if we have a Cloud Yoda, this is the wrong place for you. All right, let's keep going. Okay, so we have, all right. Okay, somebody's also first to be here. That can't be good. So it looks like the majority of the crowd that we have is our undergrad students, and we also have, so essentially let's put them together into the students bracket. Okay, that's fantastic. Thank you very much. Right now, I needed to do this because I wanted to understand as to what level you are at and what are you looking at. Very well, thank you very much. So let's proceed. So now let's begin with the overview of what cloud is, right? So when you put out the question, or when you ask somebody what a cloud is, it actually depends on, the answer depends on perspectives of various people, of what they do, of what they have interacted with in terms of cloud, right? So I have bucketized those answers into four different categories, right? One is cloud for somebody who's using it on a personal note, right? Then one is you have the organization. Then you have an organization which is providing some support to a client or customer, right? And then again, there's another perspective wherein a team within an organization is working on something to provide a service, right? So it actually depends on who you ask and what they are doing in terms of their usage with cloud, right? So the best example would be to go with personal, right? So if you ask what is cloud on a personal note, right? It would be things like uh, making sure that your pictures are saved, right? You can access your pictures anywhere, right? You don't lose, like in the earlier times, your phone had only so much of space, so you could only keep so many photographs. But now your phone comes with cloud memory, or rather cloud storage, right? Wherein you're able to click pictures and then send it directly to the cloud, and you can access that anytime and everywhere, provided that there's internet connection, of course, right? So on a personal note, it's more about storage and accessibility to your photos, your documents, your other files and folders, right? So the best example is Google Drive, or for people who use Gmail, and iCloud for people who use iPhones, right? So that is on a personal note. But when you talk about it at an organizational level, so let's say you ask a CEO or a CTO, rather, in this case, what is what is the cloud and what are you looking for in terms of cloud? They will always tell you that one of the foremost things that they will tell you is in terms of price savings, cost savings on the money that they spend on their infrastructure, on their IT infrastructure. Innovation is one of the biggest contributor to as a cloud perspective for organizations, followed by convenience and agility, right? Now all these have a certain idea to it. Like, for example, savings would be in terms of the fact that when you move to cloud, you do save a lot of money in terms of the hardware that you're going to use or that you're going to implement for your IT, right? Now, because you're not taking care of the hardware, of course, there's a lot of time for you or resources for you to do your core business, which leads to innovation, right? Now, because again, you are not dealing with a lot of hardware and there is innovation, a lot of things become convenient. Like, for example, you could automate a lot of processes, right? In that way, you don't have to do anything. Anything that was earlier done manually can now be done, can now be automated. Not that it can't be done if there is, infrastructure that you have purchased, but the only thing is that you will still need resources to take care of that infrastructure. Whereas in cloud, there's no need of that, right? If it's confusing, don't worry. It will, you will get more clarity on it as we go on through this. Okay, right? So now to answer the question, right, in terms of an IT definition, what exactly is a cloud? So a cloud is essentially resources that can be shared via the internet, right? Any resource, be that a compute service, which is your CPU and your servers, or your storage service, like your object storage or your EBSs, right? Or any of these which can be available to you in the form of an infrastructure or a platform or a software that can be accessed over the internet is cloud, right? Now, these resources can be located anywhere in the world. They can be anywhere. They can be in India. They can be on the European, on the European soil. They can be in the Americas. They can be down south in Southeast Asia. It does not matter, because you're not going to be worried about that. For you, what you want is just the infrastructure, right? It's just the resource that you can access via the internet. And similarly, any of these infrastructure or any of these resources that you're going to use, you're not going to be managing them, right? So this, in a nutshell, is cloud. So cloud is essentially a resource that you can access via the internet. Please be advised, internet is very important here, right? Internet/network connectivity is very important. Now, moving on. Now, let's look at a requirement. Okay, so let's look at this scenario wherein we are setting up a business. For example, the IMF, right? So I hope people know what IMF is. For people who do not know what IMF is, it is what Tom Cruise does, right? Impossible Mission Force, right? Okay, so let's see. Now, what happens is when you're setting up a business, right? In this case, the IMF, you're going to need a lot of information. There's going to be a lot of information that is going to be processed, correct? So for you to process that information, you would need computers, right? So we are going to put computers in a category called as compute because they have CPU. So CPU is the one that does the work, the actual work, right? The processing work. So what will you need? You will need a CPU, right? A very powerful CPU, which is then called a server. A collection of CPUs put together is called a server, right? So you will need the server to do all the computation, do all the processing of the information that is coming to you. Now, that information before it is processed, before slash after it is processed, needs to be stored somewhere, right? Which is where you will need the storage, right? Now, similarly, once you have the compute services work on the storage, which is storing that stored information which was available to you, all that processed information is going to be stored in a database because database is also a storage, but then it's at a very large scale, right? And since you guys also belong to the computer science domain, I would take it into consideration that you guys understand what a database is, right? Now, based on database, you would also need a data lake because there's a lot of information that is going to flow, right? Flow into the IMF systems for them to, process, analyze, and then set it forward to different missions, right? Now, all that information needs to be analyzed as well. So you will need an analytics service as well. So, like for example, you will need to if Ethan Hunt is going on a mission, right? They would need to know if it's a night mission. They would need to know what time does the building close, what time do people exit, right? What time is it? What time is it free? When does the flow worker comes on? Right? All of that information, right? That needs to be analyzed. And similarly, those needs to be reported as well. And for IMF, they need real-time reporting. So you will need all these requirements, right? To set up your business, to have a successful mission, you will need all of these with you, right? Now imagine if you have to do this, right? Let's just go back the page. Now, let's imagine that if you have to do this, what is the first thing that you will have to do? You will have to go to either go ahead and buy a large piece of land and set up all these services, right? So you buy servers, you buy storage, you buy databases, then you buy additional databases to make it into a data warehouse. Then you go ahead and buy more softwares to analyze and then report, right? So here what happens is there is a lot of money involved right at the very beginning, right? So if you don't have that money, you won't be able to start, right? So this is where the whole concept of cloud comes into the picture. So the first thing is where you go ahead and you have to buy so much, invest so much of money, right? For you to be able to start your business. Of course, the other part is you go and purchase a small space in an existing data center, right? But then again, you still have to produce a lot of money to be able to purchase the resources, right? Here's where cloud comes in, right? So let's look at a traditional data center. So for you to start your business, you will have to first identify the vendor. You will then have to make a lot of upfront investment, which is known as CapEx or capital expenditure. Then you will have to allocate resources to make sure that those infrastructure is being taken care of. Then there is an additional investment, which is OpEx, which is your operational expenditure. So if you have the resources, you will need to have somebody manage those resources, right? And then managing those resources is not free. You will need to spend some money to manage those resources as well, which is your operational expenses. Then you will need to look at the operations itself, right? And then again, the final thing is maintenance and upgrades. So if you're using a data center, a server in a data center, let's say it's 10 years old, right? You need to upgrade it. Whose responsibility it is? It is your responsibility. Any upgrade required on that particular server, whose responsibility? Your responsibility. So what this does is this allocates a huge resource or a huge manpower to do these activities as well, right? So again, the expenses go up. Whereas in a cloud, it's very simple. You identify the cloud service provider, you spin up the resources that you need, and you pay as you go. So the only part that you involve in is investment, right, of the operating type. So you don't have to spend a lot of money, to start your business. You just identify the cloud service provider that you want to go with. You then spin up resources. Now, spin up resources is the term used for creating resources. And in cloud, resources can be spun in as small as 10 seconds to 30 seconds. I can have a compute server up and running for me in less than 30 seconds, right? And I only need to pay as I go, which means if I use that server or the compute server for 1 hour, I only need to pay for 1 hour. Whereas in a traditional data center, I would need to pay for that data center for the amount of contract that I have entered with the data center people, right? If the and these contracts are not small. They are about, they are nothing less than 7 years, 10 years, right? So you will have to pay for that whole period, even if you're not using that resource, right? And because of all of this, what happens is you get to innovate because you as a business are able to concentrate more on doing your core business instead of managing your IT, right? So please understand that the difference, one of the major difference is, how easy, convenience. Remember the term convenience, which we used in the previous slider? How convenient it became for you to set up your business, right? So that's what happens with cloud. It gives you that speed, that agility, that convenience, right? That cost savings that you would traditionally not have if you go with the conventional method of setting up either your own data center or purchasing some resources in an existing data center, right? Okay, so this is a picture which should explain what we are talking about, right? So if you look at it, on the left-hand side, you see cloud, right? So what happens in cloud is when you run your business, depending upon the cloud service model that you have opted for, again, don't worry about it. Cloud service model is, I know, a technical jargon, but as we go forward, you will understand what that is, right? So for this slide, let's just say that for us as a business, as IMF, when we move to cloud, the only thing that we have to deal with is implementation and customization, which is going to be our core business. We implement the cloud, and then we implement in the cloud our applications, and then we customize it to what we want, right? But then if you have your own data center, if you have purchased or gotten into a contract with a data center vendor, then there is so many things that you need to look forward to. Like, for example, you would need to look forward to uptime requirement analysis, which is essentially determining how much do you need to buy, right? So in the slide, if you remember, when we were talking about the let's go to that slide, requirement servers, like how many servers do we need? How much of storage do we need? How much of database do we need? What kind of analytics are we going to perform? Is it going to be real time? And if it's going to be real time, what are the sources of the feed that's going to come to us? Is that going to come in a batch, or is that going to be real time as well, right? And then what are the types of reporting that we are going to do, right? all of this you need to know, as in you need to decide that that's what you're going to do, correct? So you can't guess. There's no guessing, or rather it is absolute guessing in your own data center. So you say that I would need servers with 128 GBs of compute, compute requirements. So 128 GB, and then so much of memory, right? And then I will need like 100 of them. I would need 100 of 200 TB storage boxes, right? Things like that. But in the cloud, it's not like that. So if you need something, you can spin it up, you can start. If you don't need something, you can just destroy it or stop it, right? And then you stop paying for it as well, right? Okay, so like I mentioned, what are the various features of cloud, right? So the first one is the cost. It becomes very cost efficient. Now understand that when we say it becomes very cost efficient, if you move from an on-prem infrastructure to a cloud infrastructure, yes, it does reduce the price, it does incur a lot of savings, but that is only step one. For you to continue to realize savings once you have moved to the cloud, you need to also have a cloud admin team which makes sure that your usage in the cloud is as per your requirement, right? A simple example is, although cloud services say it's pay as you go, right? Let's say I use a compute service, or I use a virtual machine, right, or a server for 24 hours. Now, ideally, I'm supposed to pay for those 24 hours, right? Because my job required my system to be used for 24 hours. Let's say I did not shut off that system after 24 hours, right? And then I realized this the next day, or I realized this the next day, but I couldn't go to work, right? Because it's the weekend, right? So let's say I go on Monday, and then I shut down the system. But then in this process, I have used the system for 48 additional hours, correct? So now what will happen is I will need to pay for those additional 48 plus 24 hours, correct? Whereas my payment should have only been for 24 hours. So please have that understanding as well. When we say cost effective, it means that when you move, yes, and then for you to continue to realize that savings, you need to be very you need to be very stern about the usages as well. Then the next term is elasticity. What elasticity means is cloud, the resources that you have in cloud can just move about. So move about and have more more of those resources added to it. So let's say, for example, right now you have, let's say, going back to the IMF example, let's say we are on a mission. Now, when we are on a mission, let's say to process certain amount of data, we need 100 more servers, right? So in cloud, you can do this at the click of a few buttons, right? So during the course of that mission, you can have those 100 additional servers, which will help you with computing whatever is the requirement. Let's say that mission is now over. Now, once the mission is over, you don't need those 100 additional servers. So you can just stop and terminate them. So when you terminate them, right, you're going back to your original capacity. So this concept of scaling out and scaling in so easily is called elasticity, right? The next feature is high availability. Now, what do we mean by high availability? So all of the cloud services we say are highly available. So what it essentially means is you can have access to your information, to your data in the cloud at any given point of time. So one of the examples is the objects that you store in an S3 bucket, which is a storage service available within AWS or Amazon Web Services. The availability SLA for that is 11 9, which is 99 followed by 9 more 9s, which means at any given point of time, you will have access to your data. Now, the cloud is able to do this because it replicates your data across multiple regions or multiple availability zones, right? So if you have the data, let's say if you have the picture of Ethan Hunt on a mission, right, in Mumbai, let's say you have a picture of that in Mumbai, what cloud does is it automatically replicates this to another region, which is Delhi, right? So if your Mumbai region goes down, there is still a backup available in Delhi, wherein you can still have access to that, and that piece of information becomes available to you, right? Then global access. Like I said, you can sit down in one country and you can spin up resources in any country. So I can be sitting here in one country, but let's say I'm looking for some mission related data in Europe. I can start having my resources in Europe. I can spin up my resources in Europe, right? Similarly, scalability. Now, scalability is related to elasticity, right? Scalability is where you can scale out and scale in, right? Scale out if you need more resources, scale in when your resources are not required anymore. Now, there are two types of scaling. One is called vertical, one is called horizontal scaling and one is called vertical scaling. Now, horizontal scaling is when you add the same type of resources, same configuration of resources. Let's say your server has 12 CPUs and 128 GB of RAM, right? Right now you have 5 of them. Your horizontal scaling will be you scale to have 10 of them. Your vertical scaling would be wherein you increase the configuration and the number of resources. So let's say, for example, instead of having 12 CPUs with 128 GB RAM, you could now have 24 CPUs with 256 MB RAM or GB RAM, right? Now, what happens with this is this becomes relatively easier. You don't need to shut down a system. You don't need to look for a maintenance window. This can be done on the fly, right? Which is what adds on to our next feature, which is speed. So everything that you do in cloud can be done within few seconds to few minutes, right? Based on the service, and generally requires only a few clicks of the mouse or a few lines of the code, right? So those are the features of the cloud. Now, why is everybody moving to cloud? Why is everybody talking about cloud, right? Why is cloud become such a huge terminology in the IT industry, right? So the answer to that lies from this very simple graph that was published in the newsroom from Gartner, right? So if you look at it from 2018 to 2022, which is 4 years, right? Or the expected, or rather, let's look at 2021, right? Because 2022 becomes projected, right? So if you look at 2021, you will see the rise of companies, right, employing cloud services, and in turn leading to the revenue that's being generated because of the cloud, right? So what I want to point out here is this interesting fact. So you see, in 2019, the revenue was $243 billion, and then in 2020 it was $256 billion. But in 2021, it's at $307 billion. So you see, there's almost a jump of approximately $50 billion. Now, there is a reason for that. We encountered something in 2020, right, which was the global pandemic. So what the global pandemic has done is it has driven towards a digital transformation, because of which people are now feeling, it's easier for people to work. Earlier, right, pre-COVID-19, right, when you say I work, you imagine people, you know, dressing up, getting up on time, going to work, you know, either using a public or a private transport, going to work, spending 9 hours there, you know, and then coming back, getting stuck in traffic, both, you know, when they're doing the to and fro journey, right, and coming back home and no time for themselves or family, right? That is what essentially work life was, right? But now it's not that same, you know, it's not the same. Even for you as students, right? It is very different. I mean, you're not going to school and all of that, right? But you're still getting the education that you want, right? That's required of you, right? So what's happened here is all the companies have gone through this digital transformation, wherein work from home has become the new mantra, right? Now, for people or for companies to make sure that they realize this work from home opportunity, they had to move to the cloud, right? They can't go and buy resources like we mentioned of in the data center, right? They have to, if they need computers, if they need storage, right, for those computers, right, they need to do a lot of analytics on those computers based on logs and etc., right? All of that. So this was a service. One of the services that contributed to this huge rise in the cloud revenue is known as desktop as a service, which is essentially you use the internet connection to log into a particular website or a particular application, and then in that application you launch a virtual desktop or a computer. So you launch a computer which is not your computer, but it functions as a computer, right? It behaves exactly like a desktop that you would use at work, right? Amazon Workspaces is an example of that, right? Earlier, it used to be Citrix, right? I'm not sure if you all have heard of these terms, but you will get acquainted with this eventually, right? So this was one of the requirements as to why everybody is moving to cloud, because it helps you become much more efficient. So, and it's transformed so much in terms of the savings for a company that they are able to do things that they were not able to do, right? A simple example, in fact, one of the best examples, you know, that I could think of, and this happened to me yesterday. So my company, right, we has decided that you know, we are all going to work from home, right? And then what it has done is it spent a lot of money in terms of employee satisfaction, right? So what it did yesterday was we had this 2-hour personal concert, which, you know, of Vishal Dadlani. I'm sure you must know of him, and another gentleman called Danish Saith, right? So we got a 2-hour concert, right, sitting at the luxury of our homes, right, listening to some great music and some great comedy, right? So that is what this is the transformation that's happening in terms of work life, right? And why is this possible? It's possible because of what's happened in the IT space for the various companies. Okay, so let's move on. So now, so now this is called the Gartner quadrant. I would request all of you students to please make a note of these small little topics that I tell you about and go read them to understand what they are, right? So the Gartner quadrant essentially puts companies based on these 4 categories of challengers, leaders, niche players, and visionaries, right? I think somebody has a question because I saw a hand raised. Please hold on to your question, make a note of it in your notepad, right? Or put it in the chat. Shruti will make sure that your question reaches me once we finish the session, and I will answer it for you. Thank you. Right. So coming back to the major players now, if you see on the top right corner, right, the leaders are AW. The leader is rather there's no the leader is AWS. Although they fall into the quadrant, AWS or Amazon Web Services is on the top. Is is at the very is at the most extended version of the lines, right? Followed by Microsoft and Google, they're close to each other, right? Then you have Alibaba Cloud, right? And you have Oracle, IBM, and Tencent, right? So now this is from I think the June of last year. So I'm pretty sure IBM has moved up a little further, and Microsoft and Google are almost next to each other, right? So this explains as to how people are able to look at the current trends and companies are moving forward, right? Okay. Now, earlier we spoke about, or we gathered, or we read about the common definition in terms of IT, right? But then again, now that it's becoming a global service, there needs to be a standard setup, correct? So the National Institute of Standards and Technology, in one of the papers that was published, have earmarked these 5 characteristics of cloud computing, right? The first one being on-demand self-service. What does it mean? This means that if I need a computer or a compute server right now, this becomes on demand. I can go up, visit a vendor, right, and spin that resource by myself, which becomes self-service. So on demand, because I had the demand of it, I went and I myself spun up that resource. So that becomes your on-demand self-service. Broad network access. It should be able to give me varieties of network access based on the speed that I want, based on the location that I want, etc., etc. Resource pooling, right? So the concept of resource pooling is that when you are going to a cloud vendor and reserving space for yourself, right? You're only getting a small portion of the huge resource that you have, right? So think of it as a wall, right? Now the wall has bricks. The wall is owned by a cloud service provider, and each brick contains information specific to a company, right? So in that wall, you're going to have data available from company A, B, C, D, and IMF as well, right? But there is going to be a demarcation amongst the data of each of the companies. So IMF will not be able to access company A's data, company A will not be able to access company B's data or C's data or anybody else's data, right? So what's happening is in that whole wall, all the resources, which are the storage resources, are being used, right, by different people. So this becomes a concept of resource pooling, right? Rapid elasticity. Working on the same example, we had, let's say IMF had 10 bricks. Now it needs 20 bricks. It can rapidly move and request for that 20 bricks and have it immediately. So this is elasticity. Similarly, if it does not need those additional 20, it can give it up, destroy it, or terminate it, and then go back to its original configuration. So that's rapid elasticity, right? And then measured service. So whatever service you have used is measured, and you're charged according to it in a pay-as-you-go concept. So if I'm using the storage service, if I have used 10 GB of storage, I will only be charged for 10 GB of storage for that given time, right? So in storage, it is generally GB per month. That's the type that's used, right? So if I store 10 GB for 1 month, then what is the cost of 1 GB and what is the cost of storing for a month is applied to me, right? If I store it for only 15 days, then of course that gets divided into half because I've only stored it for 15 days. All right. So let's move on. So that's essentially the attributes of cloud computing as per NIST.